Hi, welcome to my video on log function. Find the domain, range, asymptote, and base of a log equation. Part 1. This is part 1. There's another part 2 coming in the next video. Find the domain of each function. The domain is the values of x have to be greater than 0. X is greater than 0. In A, we have x, so x has to be greater than 0, where x belongs to the real numbers. Right here, we have x minus 1 is greater than 0, where x belongs to the reals, so x minus 1 has to be greater than 0. Move the negative 1 to the right to make it positive, so x is greater than 1, where x belongs to the reals. And in C, we have 2x plus 8 is greater than 0, where x belongs to the reals. That means 2x is greater than negative 8. Divide by 2, x is greater than negative 4, where x belongs to the reals. Is there any real number greater than negative 4, not equal to negative 4, greater than negative 4. And the D, we have negative 3x plus 6 is greater than 0, where x belongs to the reals. Negative 3x is greater than negative 6. Divide by negative 3, x 2, when you divide an inequality, which is less than or greater than, or less than equal to, greater than equal to, we always change its direction, so it becomes less than. So the values of x are less than 2, and x belongs to the reals. And just have a look, if you take the values of x less than 2, let's take a 1, plug a 1 in. Negative 3 times 1 is negative 3 plus 6 is 3. So notice we're reverse the direction. If you didn't reverse it, you would have done x is greater than 2. Any number greater than 2 would have been a 3, or a 4, or a 5. Put a 3 in. Negative 3 times 3 is negative 9, and the square root of negative 9, sorry, not square root, negative 9 plus 6 is negative 3, and the log of a negative number can't be done. The next one, the range of a log function. In a log function, the range is always the real numbers. Log y belongs to the set of real numbers. All log functions have their range belong to the real numbers. It's the domain that the restrictions on. X is greater than 0, or in this one x is greater than 1, or in this one x is greater than negative 4, or here x is less than 2, but the range is always real numbers for the y. Find the equation of the asymptote for each log function. The equation of an asymptote of y equals the log of ax plus d to the b is when you let ax plus d equal 0. And the equation of a log function, the asymptote is a vertical line. So we let x equals 0. So the equation of the asymptote is x equals 0. Right here we let x plus 2 equal 0. So x is equal to negative 2. So the asymptote is negative 2. When you put a negative 2 here, you get 0. You can't do the log of 0 because the log has to be greater than 0. And right here we have 4x minus 20 equals 0. 4x equals 20. Divide by 4, we get x is equal to 5. Again, when you put 5 here, you get 4 times 5 is 20. 20 minus 20 is 0. We got to be greater than 0, so the asymptote is the vertical line, x equals 5. And we have negative half x minus 3 equals 0. Negative half x equals 3. Multiply by negative 2 on each side. A reciprocal of 2, the denominator is 2, so multiplying by 2, the 2 cancels out. Negative and negative is a positive, and we get a negative 6. And again, check. Negative a half times negative 6 is a positive 3. 3 minus 3 is 0. So the asymptote with the vertical line, x equals negative 6. Okay, let's continue. Find the value of the basis for each log function. And the basis got to be greater than 0, not 1, and belonging to the reals. So that means we go the basis right here. So b minus 4 is greater than 0. So b is greater than 4. And also, that means that b minus 4 cannot equal 0. So b cannot be 4. So we got to have greater than 0. B has to be, cannot be 1. So that means b minus 4 is 1. I said 0. 1. So 4 plus 1. So b cannot be 5. Sorry about that. I have b is not 1. I wrote down a 0 here. So x minus 4 cannot be 1. B cannot be a 5. Check. What is 5 minus 4? 1. We cannot have a 5. And we got to have all numbers greater than 4, but not a 5. And we have negative. The base is negative 2/3 b minus 12. Got to be greater than 0. Negative 2/3 b greater than 12. We multiply by 2 to get rid of fractions. So 2. So we get negative 3b is greater than 24. Now divide by negative 3. And we divide by a negative number, it reverses, and we get negative 8. So b, all values of b have to be less than negative 8. And it also, we have negative 2/3 b minus 12 cannot be 1. So negative 2/3 b cannot be 1 plus 12. Negative 2/3 b cannot be 13. And we can also think about multiplying by negative 2/3 on each side. 13 times negative 2/3. And notice that's positive 6/6, which is 1 because they cancel. 2's cancel, 3's cancel. Negative and negative positive cannot be. And that's 13/1, so there's a negative 26/3. So b is less than negative 8, and b cannot be negative 26/3. So there's some extra questions when we work out the equations later on that we have to keep track of. So remember, the range of a log function is reals. The domain got to be greater than 0. The asymptote is equal to the value of x that's to the right of the log. And the basis got to be greater than 0 and not 1. So that ends this video. And if you like my video, click on the like button. And if you're not a subscriber, click on the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.